Hello and welcome to this section of the tutorial. What we're going to do here is continue working with higher order derivatives, increase the complexity of our example problems just a little bit, but we're going to be doing exactly the same process. We're going to be taking derivatives in sequence, arriving at the second derivative, the third derivative, and so on, giving you some practice just with a little bit more complicated problems to kind of get in our way a little bit, give you a little bit of practice with dealing with that. So, as an example, let's say we had a function f of x is the sine of x squared, where x squared is what's being operated on with the sine. Now what we want to find in this case is the third derivative, d cubed f dx cubed. So we're writing it in that notation just to give you a little bit of a flavor for writing it and seeing it different ways, but it's the same as f triple prime of x. So the first thing we need to do is find the first derivative. So we say df dx, that's the first derivative, is going to be the derivative of this function. But notice we're going to have to use the chain rule here because we have sine and then we have another function on the inside of it. So we look at the big picture of the sine and we take the derivative of that first. Cosine, we leave the inside, x squared, intact, but we can't stop there. We have to multiply by the derivative of the inside. Derivative of x squared is 2x. Okay? So just to sort of keep it all compact on the same line, when you rewrite this, you'll have 2x cosine x squared. And that's the first derivative. So if your question was find the first derivative, that would be the answer. Obviously, we have to keep going though. So let's find the second derivative of this function. So we write it as d squared f dx with a 2 there. That's the second derivative. The way we do that is we find our first derivative and we take the derivative again. But notice things have gotten more complicated because now we have cosine x squared, but we also have another function of x on the outside multiplied by our cosine. What do you do when you have two functions multiplied by one another? You have to use the product rule, right? So we have the first function times the derivative of the second plus the second times the derivative of the first. And if it helps you visualize this a little bit, put some little parentheses around this. It's not going to change a thing, but you can visualize this as a function multiplied by another function. So we're going to start out with first function times the derivative, cosine of x squared. So first times the derivative of the second plus the second function times the derivative, just to keep it consistent, I'll put the 2x here, times the derivative of the first. So first times the derivative of the second plus the second times the derivative of the first. All right, so second derivative, you know what, I'm just going to keep it here, not keep rewriting this over and over again. So what this is going to be, 2x, what is the derivative of this term? Again, we have to use the chain rule. Derivative of cosine is negative sine x squared. We have to multiply by the derivative of the inside, which is 2x. Okay, so we've done that. What about over here? Plus cosine x squared. What is the derivative of 2x? It's just simply 2. So that one's much, much easier. So let's go ahead and rewrite everything here. So we have a negative sign, negative. 2 times 2 is 4. X times x is x squared. So we have 4x squared sine x squared plus, the 2 comes out, cosine x squared. Right? So we have negative 4x squared sine x squared times, or plus 2 times cosine of x squared. So this is d squared f dx squared. This is the second derivative. If our problem had just said, let's go ahead and take the second derivative, we would just stop right there. But we're not. We have to take the third derivative. So we have to look at this function and take the derivative again. So notice how it's getting more complicated. We started with this simple function. It mushroomed out to this, and then once we dealt with that, it mushroomed out to something bigger, so we're dealing with something more complicated as we go down. So, third derivative of the function f with respect to x. We just have to peel it apart one step at a time. So what we have, again, is a first term and a second term, but this term has two functions, again, multiplied by one another. And to help you visualize that, you can kind of put, again, a little parentheses around this function multiplied by this function. So let's do a product rule on this, right, to take this derivative. So what we will have is negative 4x squared first times the derivative of the second, sine of x squared, first times the derivative of the second plus the second function, sine of x squared, times the derivative of this first function. Let me put it in brackets to be consistent. Negative 4x squared. First times the derivative of the second plus the second times the derivative of the first. Now this guy is not a product rule because this is just simply a constant out in front. So the constant is going to sit here. What is the derivative of cosine x squared? Derivative of cosine is negative sine. So let's keep it in parentheses, negative sine x squared. But we can't stop there. We have to multiply by the derivative of the inside. So we multiply by 2x. And that's the derivative here. So we have to use the chain rule again here. But since this is just a number, it can just sit out in the front. We take the derivative of this, cosine being negative sine, times the derivative of the inside. So it looks a little bit ugly. Let's tidy it up a little bit. All right, and take these derivatives. So what we're going to have is negative 4x squared. And then in the inside of this bracket, we still have to take the derivative of this sine, but we have the x squared in the middle, so the derivative of sine is cosine x squared. We have to multiply by 2x because of the derivative of the inside. And then we have plus sine of x squared. And on the inside here, we take the derivative of this guy. 4 times 2 is 8, so we have negative 8x, because we subtract 1 off the exponent, that's that derivative. Plus 2 times 2 is 4, so we have 4x, and actually we have a negative here, so this will be a negative sign. 4x times the sine of x squared. This really is the answer. I mean, you could probably circle that in a pinch on your test, but we want to get a little bit more elaborate and simplify it a little bit more if we can. So what we're going to have here, this first term, we have a negative here, so we'll keep that negative there. 4 times 2 is 8, so we'll have 8. X squared times x is x cubed, so we'll have x cubed. And then we'll just keep the cosine, cosine x squared. So that takes care of this first term. All right, and then over here, let's go ahead and just rewrite it in an easy to see fashion. This negative 8x is going to come out front, negative 8x times the sine of x squared minus 4x times the sine of x squared. So we could stop right here, and it's perfectly fine to do that, but notice that what we have a sine x squared and a sine x squared. So, and we can basically subtract these guys because we have common terms everywhere. We have x sine x squared, x sine x squared. So we basically have everything the same from here on. We just have different coefficients. So we can add and subtract those just like, 3x minus 2x. We can add those together as well. So the final answer is going to be the third derivative of this function with respect to x is going to be equal to negative 8x cosine x squared. Now what we have is negative 8 and negative 4, so that's going to give us negative 12. Negative 12 what? Negative 12x sine x squared, because we're combining those terms. So the third derivative is negative 8x. This is going to be 8x cubed. Coming from there, I just forgot to write that. Cosine x squared minus 12x sine x squared from right there, and that's the third derivative. So definitely more involved, you see, but it's not more involved because of the idea of what we're doing. It's more involved because of the specific function we have. Because this basically required the chain rule to deal with, which broke this function out into a little more complicated function when we took that derivative. Once it was in this form, taking the next derivative forced us to use the product rule, which made it even more complicated. And then whenever we got down to here, we had to deal with the product rule on top of the chain rule. To do the third derivative. Imagine if you had to take another derivative of this again and again and again, it's going to get more complicated each and every time. So that's sort of the thing to keep in mind there. The idea is not any more complicated, but your execution is very, very important to make sure you don't make any errors. So let's go ahead and get some more practice here. What if we had f of x is equal to 3x over 4x plus 5. And let's say we wanted to find f triple prime of x, third derivative. You could definitely approach this as a quotient rule, bottom times derivative of the top minus the top times the derivative of the bottom squared. If I were doing a first derivative, I'd probably just do it that way because I could leave it in that final form and be done with the problem. But since I know I'm not doing that, I'm going to end up taking two more derivatives. So if I have the bottom squared, then I'm going to have more complicated things to deal with that bottom that's going to be squared. And every derivative I take, I'm going to have to keep doing that over and over again. So I prefer, even though you don't have to do this, I mean, I encourage you to work it both ways. You'll get the same answer. But another way to write this is just 3x times 4x plus 5 to the negative 1. This is exactly the same thing, and you're definitely still going to have to use the product rule here, but the nice advantage of it is you don't have the long, lengthy thing you have to do for the quotient rule. So in order to find that first derivative, you do first times the derivative of the second plus the second times the derivative of the first. So we'll have 3x times the derivative of this guy. All right, now at some point here, notice when I did this problem, when I started doing this problem, when I did the product rule, I showed you, okay, first times the derivative of the second plus the second times the derivative of the first. And I showed you that, and then in the next step, we took the derivative. I've been trying to do that up until this point because it really makes it clear what's happening. I'm writing everything down, right? At some point in your study of calculus, you're going to need to relax that for yourself. When you feel like you understand what you're doing enough, you're going to have to, you don't have to, it's just that it's going to take an enormous amount of paper to keep writing that over and over and over again. So at this point, I'm going to mix it a little bit, but for this problem, when I say first times the derivative of the second, I'm going to go ahead and take this derivative right here inside this bracket. And I'm going to keep doing that in line, and that's going to save a little bit of paper. I'm not really skipping steps. I'm just not explicitly writing this part out all the time. You're going to find that you're going to need to find the right breakpoint for yourself when you need to start doing that for yourself. And I'm leaving that part up to you. But for now, I'm going to go ahead and start doing it, at least in some of the problems. So first times the derivative of the second. The derivative of this guy is negative 1 times the inside, 4x plus 5, raised to the negative 2 because I subtract 1 off, but then I have to multiply by the derivative of the inside, which is 4. Because the derivative of this is 4, derivative of this is 0. So this bracket quantity is the derivative of this, right? We take the exponent down, this to the negative 2 times the derivative of the inside. So first times the derivative of the second plus the second, 4x plus 5, negative 1 times the derivative of the first function, which is 3. So again, I'm not writing down with the primes everything, I'm just taking the derivatives in the same line. The reason you kind of need to do that is because I'm going to take 3 derivatives. If I do that for everything, it's just going to take an enormous amount of board space. So, first derivative, just to clean it up a little bit, 4 times 3 is 12. I have a negative here. Negative 12x, 4x plus 5, negative 2. Plus, 3 comes out, 4x plus 5, negative 1. So first derivative, negative 12x, 4x plus 5 to the negative 2, plus 3, 4x plus 5 to the negative 1. So this is the first derivative. That's just the first part of the problem. Now, let's find the second derivative, f double prime of x. So I need to look at this function and treat it, and take the derivative. So here I have two functions. I've got a first function times a second one, so I'm going to have to do the same sort of thing, right? So what I'm going to have, just to make it a little bit more clear, let me take this implied parentheses and write it around the negative sign. So first times the derivative of the second. First function, let's take the derivative of this right now. We'll have a negative 2, 4x plus 5, negative 3. So we subtract 1 off the exponent. Multiply by the derivative of the inside, which is 4, because the derivative of this is 4 and the derivative of that is 0. So first times the derivative of the second plus the second function, 4x plus 5, negative 2, times the derivative of the first function. What's the derivative of this? It's negative 12. Okay, all of this is the derivative of this guy. But we need to continue on because we have to take the derivative of this guy. So we'll have the 3. Let's take the derivative of this. The negative 1 comes down, 4x plus 5. Subtract 1 off the exponent gives us negative 2, but we're not done. We have to take the derivative of the inside, which is going to be 4. Derivative of this is 4, derivative of this is 0. This is the second derivative. Okay? Let's go ahead and clean it up a little bit. F double prime of x is equal to. So what we have here is 2 times 4 is 8, 8 times 12 is 96, negative times negative is positive. So we have 96, we do have an x here, and then we have this guy, which is 4x plus 5, negative 3. And then over here we have negative 12, 4x plus 5, negative 2. And then here we have 3 times 4 is 12. We have a negative sign, so we'll do this, negative 12, 4x plus 5, negative 2. Now look at what we have here. This is all fine and dandy, but here we have negative 12, but we have the same base here, 4x plus 5 to the negative 2, 4x plus 5 to the negative 2. The only difference is the coefficients, so we can combine this and make it even simpler. F double prime of x is equal to 96x, 4x plus 5, negative 3, and then we have negative 12 minus 12 is negative 24, 4x plus 5, negative 2. And I know it's a pain, believe me, but it's really to your advantage to simplify these things as much as possible, because now I need to take another derivative to get the third derivative, and if I left it like this, I'd have even more work to do. So f triple prime of x, I just look at what I have here and take the derivative again. Again, I have a function multiplied by this other function. So I do the first function, 96x times the derivative of the second function. So I'll have a negative 3 come down, 4x plus 5, subtract 1 off, negative 4, times the derivative of the inside, which again is 4, just like it was the last time. So first times the derivative of the second plus the second function, 4x plus 5, negative 3, times the derivative of the first function, which is just 96. All right, so that takes care of the derivative of this thing. Now let's work on the derivative of this. So I have negative 24, that's a constant that just stays out front, multiply by this exponent, negative 2, 4x plus 5, to the negative 3 because I subtract 1 off the exponent. Then I'm done with that, but I have to multiply by the derivative of the inside because I'm using the chain rule. You see, I'm using the chain rule over and over and over and over again in these problems. So that's really the answer if you had to circle it. All right, let's try to go ahead and wrap this guy up. What we'll have is the third derivative of x is going to be equal to, what we have here is 96 times negative 3 times the 4. So what we're going to get is 1152. We have a negative sign on the front. So I have negative 1152. And then we have an x here from here. So we'll have the x. And then we'll have 4x plus 5 to the negative 4. Okay, that takes care of this first term. Now the second term here is plus 96, 4x plus 5, negative 3. And the third term, 24 times negative 2 times positive 4 is going to give us 192, positive 192 because negative times negative is positive. So we'll have plus 192, and then we'll have the same guy here, 4x plus 5 raised to the power of negative 3. So you know, you could circle that if you're in a pinch, but if you really look at it a little more carefully, we can combine these terms because this is exactly the same as what we have here. So we have 192 plus 96. It's going to give you 288. So let's go ahead and rewrite this guy. Final answer, f triple prime of x. All right, now notice we have a negative exponent. So just for kicks, let's go ahead and write it as negative 1152x. That's on the top. And then on the bottom, we'll bring this down. So we'll have 4x plus 5 to the positive 4 power. So all we did was bring this to the bottom. All right, and then what we're going to have here is, when we combine these two terms, 96 plus 192 is 288. That's going to be in the numerator, 288. And then we're going to bring this denominator, because after we combine these terms, we're just going to have the one denominator here, 4x plus 5 to the positive 3. And it's a triple prime there. So the third derivative is negative 1152x over 4x plus 5 to the 4th power plus 288 over 4x plus 5 to the 3rd power. So here we've ratcheted up the complexity a little bit, But it's, anytime you see a fraction like this, it's going to make things a little bit harder because you're going to have either a quotient rule to do if you do it that way, or a product rule to do if you write it the way I did. If you did not do this, and if you just use the quotient rule 3 times, you would still get the right answer. It may not look exactly like this because your simplification may end up being a little bit different, but mathematically it'll be exactly the same answer. They're both equivalent ways of doing the same thing. So we rewrite our function, we take the first derivative, use that, take the second derivative, use that, take the third derivative. It just gets a little more complicated, especially when you have things like this running around inside of an exponent, because you'll have to use the chain rule every single time you evaluate one of those guys. So it's really, really, really worth your time to simplify. As you get each derivative, simplify the answer so that whenever you take the next one, you have less work to do. I know it seems like a pain wasting your time simplifying something, but you actually save time in the long run if you do it. All right, what if we have, this problem won't have quite as many steps, f of x. What if we have sine of x minus the cosine of x? And what if we want to find the fourth derivative of x? And remember, I told you sometimes you write it with a kind of a 4 elevated in parentheses like that. So that's what we're doing here. Now if we want to find that fourth derivative, we're going to do exactly the same thing as we do all the time. We take the first derivative first. All right, what is the derivative of sine? It's cosine of x. Minus, what is the derivative of cosine? It's negative sine of x. So we just rewrite this as cosine plus sine of x, right? So do yourself a favor and don't try to combine too many things here. Write the minus and then write the derivative in parentheses and then simplify it again. It'll just help you out there if you sort of split the steps up when you can. Now for the second derivative, we just simply take a look at this and take the derivative again. The derivative of cosine is negative sine of x. The derivative of sine is cosine of x. So there's really no more simplification to do there. That's the second derivative. So then we look at the third derivative, triple prime of x, negative. What is the derivative of sine? It's cosine of x. What is the derivative of cosine? It's negative sine of x. So we have negative cosine minus sine of x. And then finally, the last one, which is the fourth derivative, what is the derivative of cosine? I still have the negative out there. Derivative of cosine is negative sine of x minus, what's the derivative of sine? It's cosine of x. So the fourth derivative of this function that we have positive sine of x minus cosine of x. And that's the answer, sine minus cosine. So it looks kind of funny because you start off with your function, which is sine minus cosine. You take 4 derivatives, and you get back to exactly the same thing you start with, sine minus cosine. That's a little bit crazy. The reason that happens is because when you look at it, the derivative of sine is cosine, but the derivative of cosine is negative sine. So if you keep taking derivatives, enough of these trig functions of sine and cosine, they'll flip back and forth. The sign may be different, but they'll flip back and forth. Eventually, if you do it enough times, you can kind of get back to where you started from. So if you were to plot this function and then plot its fourth derivative, it would look exactly the same because it's just exactly the same function. But mathematically, you don't need to worry about that or think about that. Mathematically, you just bang through each step, as nicely as you can, keeping track of the signs. The challenge with that guy is because derivative of cosine is negative sine, to keep your negative signs wrapped up, and when you do your multiplication to get the right sign in the end. If you try to do it all in your head, you're probably going to eventually miss a sign. Okay, our final problem is going to be, it's going to look a little easy, but you'll see it'll take a little bit of work. 3x to the 8th power plus 3/4 x to the 6th power minus 4x to the 3/4 power plus 2x to the negative 1 power. And what are we trying to find? We're trying to find the fourth derivative. So what we want to find is fourth derivative, or another way to write it is with a 4 up there. So we just do 1, 2, 3, 4. The only reason it's challenging is because you've got these fractions here. You've got a fraction here, and you've got a fraction there, and you've got a negative exponent there. So it's really an exercise in keeping your work straight. F prime of x. Okay, so we're doing a little multiplication here. 3 times 8 is 24. X to the 7th power. We subtract 1 off. All right? Over here, we're going to have 3/4 multiplied by this exponent. I'm going to write it as 6 over 1, x to the 5th. We'll come back and do the simplification later. Don't try to do too many things at once. Minus 4, but then we're going to multiply by 3/4 x. And what is 3/4 minus 1? If you think about it for a second, 3/4 minus 1 is negative 1/4. All right? And then what we have over here is 2 times negative 1, x. Subtract 1 off the exponent, we'll get a negative 2. So let's go ahead and simplify our math here. So what we'll have is f prime of x is equal to 24x to the 7th plus, what do we have here? We have something we can do a little bit of simplification ahead of time. We'll divide by 2 there, and divide by 2 there. That will help us a little bit. So what we'll have over here, 3 times 3 is 9, 2 on the bottom, x to the 5th. All right, and then what we'll have here, this 4 is going to go out with this 4, so we'll have 3x to the negative 1/4. 3x to the negative 1/4. Here we'll have minus from this 2x to the negative 2. And congratulations, that's the first derivative. All right, so let's go and do it again. Do a second derivative. F double prime of x is equal to, what's 24 times 7? It's 168, but let's go ahead and write it for right now as 24 times 7, just so you know what we're doing. X to the 6th power, subtract 1 off that exponent. Plus 9/2, we're multiplying by 5, so we'll leave it like that for now. X to the 4th power, subtracting 1 off of this exponent. Minus 3 multiplied by negative 1/4, coming from here. X. Now, what is negative 1/4 minus 1? If you do that in your calculator, if you think about it for a minute, you'll realize it's negative 5/4. Just fraction subtraction there. And then over here, you'll have negative 2 then multiply by negative 2 from that exponent, x. Subtract 1 off, you'll get negative 3. So we did a lot of work, but we didn't do a lot of math there. So let's go ahead and simplify it. F double prime of x. 24 times 7, if you do that in your calculator, is 168. 168 x to the 6th power. All right, plus. Here you have 9 times 5 is 45 over 2. You can't really simplify that much, so we'll do 45 over 2, x to the 4th power. Negative times negative is positive. This will be 3/4, x to the negative 5/4. And then here we have a plus 4x to the negative 3. That, my friends, is the second derivative. Now let's move on down the line. Take the third derivative. F triple prime of x. Same process. What we'll have here is 168 times this exponent 6, x to the 5th power, subtracting 1 off that exponent. Then we'll have 45 over 2 multiplied by this exponent, x to the 3rd power, subtracting 1 off of that exponent. Then we'll have 3/4 from here multiplied by this exponent, negative 5/4, x to the negative. Now if you have negative 5/4 and subtract 1 more, or subtracting 4/4 from it, which is subtracting 1 more, you'll get negative 9/4. You'll get good at subtracting these fractions after a while, I promise you. And then here you'll have plus 4 times negative 3 from this exponent, x to the negative 4, subtracting 1 off of there. So let's go ahead and do this math. F triple prime of x is equal to, what's 168 times 6? It's 1008, x to the 5th. And what we'll have here, we'll strike this out and make this a 2, just doing a little simplification. What's 45 times 2 here? That's a 90, x cubed. And what we have here is a negative sign, so it will be negative. 15 on the top, 16 on the bottom, so we'll have 15 on the top, 16 on the bottom, x to the negative 9/4. Here we have a negative 12x to the negative 4. And that is the third derivative. All right, so we're doing one more and then we're done. So f, fourth derivative of x is equal to. So we'll have 1008 times this exponent of 5, x to the fourth power, subtracting 1 off of this guy, plus 9 times 3 is 27, so that'd be 270, x squared, subtracting 1 off of this exponent. And then we'll have 15 sixteenths times this guy, negative 9 fourths, x to the, if you take a negative 9 fourths and subtract 1, it's the same thing as subtracting 4 fourths, right? So you think in terms of your denominator, 4 fourths. So that's going to be negative 13 over 4 when I subtract that. And then I will have negative, 12 times 4 is 48. It's going to be positive since I'm multiplying these, so it'll be 48 x to the negative 5, subtracting 1 off of that exponent. Here we should be able to write the final answer. Fourth derivative of x. What's 1008 times 5? It's 5040, 5040, x to the fourth power, plus 270x squared from this term. And here, is there anything we can do to simplify that? All we can really do is make it a plus because negative times negative. 15 times 9 is going to give me 135, and 16 times 4 is going to give me 64, and then it'll be x to the power of negative 13 fourths. And then here we'll have, let me go ahead and make this clear, 13 fourths like this, and this would be 48 x to the negative 5. That's your fourth derivative. 5040 x to the fourth power plus 270 x squared plus 135 over 64 x to the negative 13 fourths plus 48 x to the negative 5. A real bear, I'll be honest with you, but mostly it's fractions. It's not a real bear because of what we're doing. It's a real bear because everywhere I have a fraction or a negative exponent, that's why I'm doing this. Because this is the kind of thing you'll really see on your test and on your bonus or your quizzes or whatever like that. It's not hard to keep taking these derivatives. You know how to do it, but then you're constantly dealing with multiplying fractions, and it just takes time for you to get the confidence to know that banging it out like this is the right thing to do. Students get a little weird when they start seeing this and they start to see 45 over 2 and they see 9 fourths and they see 13 fourths and they're like, I've done something wrong for sure because this does not look like a nice answer. Well, in calculus, a lot of times you're not going to get nice answers. I think you've seen that up till this point. You might have square roots running around everywhere. You might have fractional exponents, negative exponents, and all kinds of crazy things running around. As long as you're doing the rules correctly and you can back those up and you know you're doing it right based on the rules of calculus, then you're doing absolutely nothing wrong. The answer that falls out, this does not look like a beautiful answer to me, but it's the right answer, and that's really all that matters. So watch this section as many times as you need. When you're taking these higher order derivatives, all you're doing is taking the derivatives in sequence. First derivative, second, third, fourth, fifth. I've tried to give you a variety of problems to flex your muscles and give you some confidence. If you can master these, you should be able to go into your test and do almost any derivative, higher order derivative that your teacher might be able to give you. So definitely practice, build your skills, and build your confidence.